I'm going to do a video about integration by parts, which is another integration technique besides substitution. And integration by parts is an integration method which works for products of functions derived from the product rule of differentiation. And it's kind of like the inverse of the product rule, except it's really more specific because it's really like you really have to make sure that you set up u and v, your two functions, in the perfect way so that it works. Speaking of, here's how the formula works. The integral of u dv equals uv minus the integral of v du. This is what you would use. With functions integral, what you want to find is u dv, and you want to try and set u and v in a way so that uv minus v du is something you can calculate easier, and then that's gonna be then you can find out the answer to u dv. So if you want to derive this from the product rule, the product rule says that the derivative with respect to x of the product of two functions u and v equals u times the derivative of v with respect to x, so u times dv dx, plus same thing but reversed, v times du dx. And now what we're going to do is going to take the integral of both sides with respect to x. And this side as well. And so since integration outdoes differentiation, on the left-hand side, we're just left with uv equals the integral of u times dv dx. We're going to split this up into two integrals because of like the sum rule, and the first term is just the integral of u times dv, because you can think of it as the dx's cancel, plus the integral of v du, because it's v times the du is left once the dx's cancel out. So, and now what we're going to do is, if you just bring what uv to the right hand side, and so you flip the equation and you subtract the integral of v du from both sides, then you get this equation, and that's the equation for integration by parts. So now let's do one example of find the integral of x times natural log of x dx. So we're only gonna, for this one, we're only gonna have to do substitution once. Many times you have to do it twice. Do it once, and then to find the v du integral, you have to do it again, maybe even 3 times. But for this one, you only have to do it once. So first we have to find u, what u is, what we want to set u as, what we want to set v as, and then we have to find out du and dv. So first, what we're going to set u as in this one, we want something so that once we find dv, one of the things of x or natural log of x jumbles in with the dx, so that way we get the left-hand side of the formula. So what about we set u as natural log of x, and we set v as x squared over 2. This way, the integral of u dv for this one, becomes, when we find dv, dv over dx is x in this case because the 2 comes down and then the 2's cancel out. So dv is x times dx. This is the reason why we chose x squared over 2 for v. And du dx is 1 over x, so du is dx over x, or 1 over x times dx. It's going to write dx over x. So now we have all 4 of them. Now we can see why this works, because dv is x dx, and all that's left is natural log of x, which happens to be u. So that way, this integral is integral of u dv. Now this is equal to uv minus v du. So the integral of x, natural log of x, dx equals, so what's uv? First you have to just multiply u and v. Natural log of x times x squared over 2. We just multiplied u and v, and then minus the integral of v. V is x squared over 2 minus the integral of x squared over 2 times du. Du is dx over x, so it's going to be dx over x. Sometimes it looks funky to see a variable in the denominator under dx, but in this case it is. So to simplify this x cancels out with one of the x's in x squared. So we're just left with this equals natural log of x times x squared over 2 minus the integral of x over 2. Dx. So x over 2 dx is x squared over 4, because we can bring the 1/2 out front. And then it would just be the integral of x, and the integral of x is x squared over 2, and then 1/2 times x squared over 2 is x squared over 4. So it'd be natural log of x times x squared over 2 minus x squared over 4. So now it's just algebra, and we're going to multiply the top and bottom by 2 on the first term, so we can combine them with the other terms, which all into one fraction. So you get that 2 natural log of x times x squared minus x squared over 4. And one more step, we're just going to factor out x over 2 x squared. That's going to be our answer. So our final answer, I'll just actually write it underneath. Our final answer is x squared times natural log of x minus 1. Sorry, it would be 2 natural log of x minus 1 over 4. And then, never forget, plus c. So that's our answer. And so that's an example of integration by parts. I'll see you next time. Bye. Be sure to watch the next video.